2.4 linear programming, Simplex method, maximization problems. So we've got a lot of steps here, but on the bright side, we can break them down a little bit. The first 4 steps is just set up the problem. And we do exactly what we did in the last lesson. The next 4 steps is more of what we think of as the simplex method. So step 5, you look for the most negative indicator. This is the number on the bottom. You're looking for negative numbers on the bottom. So most negative. And I want you to do something here. I want you to circle the column. Circle the column containing the most negative indicator. You'll see when we get to an example. Number 6, form the necessary quotients. So basically, we're going to divide the number on the right by the number on the in our circled column, and we look for the smallest non-negative quotient or smallest ratio. Once you find that, I want you to circle the row. Notice it says something about if there's a tie. Sometimes there'll be a tie. If the 2 quotients are both equal and smallest, choose the pivot in the row nearest the top of the matrix. So that kind of tells you what to do in case of a tie. But I want to circle the column containing the most negative indicator, circle the row containing the smallest quotient. And then there's going to be a number that you've circled twice. That's going to be the pivot element. The pivot element is the number you've circled twice. Step 7, we're going to use row operations. So row operations is where we take like row 2 minus 3, row 1, that kind of thing. And then step 8, we look at those indicators again. And if all of those indicators are positive or zeros, then we're finished. Any negative numbers on the bottom, you're not finished. You have to do the process again. All right. So it's kind of a loop where you do these 4 steps, and then if you're finished, you're finished. But if you're not finished, you have to go back and start over again. And then once you're finished, once you have all positives on that bottom row, or all positives and 0, then we can read the final solution. So example 1 is a problem that we've done before. We did it in the last section by graphing. This is the method of corners, and I went ahead and showed you the graph. But when we used the method of corners, you plugged those corners into the objective function. And it looks something like this: 25 times 0 plus 30 times 0 was 0. And 25 times 0 plus 30 times 60 was 1800. And 25 times 25 plus 30 times 40 was 1825. And again, we've done this problem before. 25 times 65 plus 30 times 40 was 1625. And so we could see this was the maximum value at the corner point of 2540. We know how to do this using the method of corners, but we're going to learn a new method for doing it, the simplex method. And again, the simplex method is going to be good for 3-dimensional, 4-dimensional, 5-dimensional, bigger problems. When we only have a 2-dimensional figure, it's pretty easy to use the method of corners, but if we're 3 dimensions, it's really hard to graph. So this simplex is going to come in handy for more complicated problems. First thing you want to do, of course, is set up your initial simplex Tableau. And that means we need to install some slack variables. So go to your main inequalities and put in a slack variable. You've got 2 main inequalities, so you have 2 slack variables. I don't really need those for my Tableau. I needed them for my graph, but not for my Tableau. All right, so let's list out the variables. We've got x1, x2, s1, s2, and z. And my first inequality says 1x1, 1x2. There's 1s1. And then that equals 65. Second inequality, I've got 4x1 and 5x2. I don't have an S1, but I do have an S2. No z's, and it equals 300. Underline. Now remember, you've got to have standard form. So we subtract these variables over, and so you're going to have negative 25 and negative 30. Don't need any slacks because it's already an equation. Don't forget about your z. And once we cleared all that out, it's going to equal 0. So this is what's called our initial simplex tableau, or our first one. When you see negatives on the bottom, that's your clue that this is not our optimal solution. This is not optimal. And if you read a solution from this table, you've got some basic and some non-basic variables, but x1 is a non-basic, and we know its value is 0. And x2, same thing, it's non-basic, its value is 0. And I'm going to ignore the slack variables for now and just go straight to z. Z is a basic variable, so we can figure out its value. It's going to be 0 divided by 1 is 0. So what's interesting about this, I think, is this solution just so happens to correspond with this corner point on my graph. I've got x1 is 0, x2 is 0, and your z value is 0. But we need to do the simplex method because this is not optimal. Because this is not optimal, and how you recognize that is from those negative numbers on the bottom. When I see negative numbers on the bottom, I know I'm not finished. And so those steps, if you go back to those steps, you needed to look for number 5 said locate the most negative indicator. So the most negative indicator is negative 30. Circle that column. Now I see some students getting lazy and don't want to circle the column, but trust me, do it. Circle that column, don't be lazy. Now we need to look for the least positive, or the, what do they say? Smallest non-negative quotient. So quotient of what? Look at your numbers in the column and you're going to divide by the numbers over on the right. So for my first number in the column that I circled 1, we're going to take this number over here on the right side and divide by that number 1. All I'm doing is I'm looking at this one and I'm looking at the 65. 65 divided by 1 is 65. Okay? Do the same thing with the 5. 300 divided by 5 equals 60. And you don't need to mess with the bottom. You just need to mess with the inequalities there, or now they're equations, I guess, with our slack variables. But the smallest non-negative, or the least positive, is this one, 60. 60 is less than 65. So I want you to circle that row that produced that 60. Don't be lazy, just do it. Okay, trust me on this one. Circle the column, circle the row. One of the numbers has been circled twice. I want you to highlight that somehow. So circle it, circle the number that has been circled twice. That is called your pivot element. You need that number to figure out the next step here, okay? So we're going to use that 5 to zero out the next couple of numbers. We want to zero out this 1, and we want to zero out this negative 30 using the 5. So think about what we've got. Okay. I'm going to write a new table. Leave a little bit of room so I can write. But let's see. I need to change that top row. That top row is going to change. I need to change a 1. I need to change my 1 using this 5. And so the rule that you're going to use, or I would use, is probably something like 5 row 1s minus row 2. Okay, 5 row 1s minus row 2. So 5 of these minus this, that's going to be 5 minus 4 is 1. 5 of these minus this is going to be 0. 5 of these minus this is 5. 5 of these minus this is negative 1. 5 zeros minus 0 is 0. Bar. 5 65s minus 300 5 times 65 minus 300 is 25. Okay. The row that you circled is your pivot or your pivot row, and we don't need to change that. So leave it alone. 4, 5, 0, 1, 0, 300. We didn't need to change that one. We did need to change the bottom one. We're looking at the negative 30, and we have to change that using the 5. So I think the best thing to do is to say row 3 plus 6 row 2s. That'll be negative 30 plus 30 is 0. So do that all the way across. All right. I've got negative 25 plus 6 of the 4s. So negative 25 plus 6 of the 4s is negative 1. And negative 30 plus 6 5s is 0. 0 plus 6 of these is 0. 0 plus 6 of these is going to be 6. 1 plus 6 zeros is 1. And this one, row 3 plus 6 row 2s, that's going to be 0 plus 1800. So that's my next simplex tableau. And again, what I'm looking at, I see that negative immediately. And that negative 1 tells me that this is not optimal. Which means I'm not finished. Okay, I can still read a solution here. And if I read a solution, I'm going to see x1 is a non-basic variable, so it's 0. x2 is a basic variable, so I look at the 5, which should make me look at the 300. I'm going to divide 300 by 5, and I get 60. And then I'm going to ignore the slack variables for a second and look at z. Z is another basic variable. You can do 1800 divided by 1 is 1800. And so I can read a solution, but again, what you're looking at is that's one of the corner points. Specifically, it's this corner point. x1 is 0, x2 is 60, and your z value was 1800. Okay? But we're not finished. When I see a negative, I know I'm not finished. So I have to go back and loop back and do those steps again. So step 5 says look at the most negative indicator. Well, there's only one negative, so it has to be this one. Circle that column. Trust me, just do it. Then you have to find the ratios of 25 over 1, that's 25, and 300 over 4 is 75. So the least positive is that one, 25. Circle it. Don't be lazy, just do it. The number that you've circled twice is your pivot element. That's the one you use to make these two 0. All right, so we need a new table. That's not enough room. Kind of running short on room here. The pivot row can stay the same. I don't need to do anything with that. But I need to zero out this 4 using the 1. And so your rule looks like we can do row 2 minus 4 row 1s. That should do it. 4 minus 4 is 0. And then row 2 minus 4 row 1s, it's going to be 5 minus 0 is 5. Row 2 minus 4 of those 5s, that's going to be negative 20. Row 2 is 1 minus 4 negative 1s, that's going to be plus 4. 1 plus 4 is 5. Use a calculator if you need to. 0 minus 4 of these zeros is 0. 300 minus 4 of the 25s, that's going to be 100. 300 minus 100 is 200. Underline. Now on the bottom, I've got to get rid of this negative 1, and you always have to use the circled element. So that's not too hard. I can do row 3 plus row 1. Just add them together. -1 plus 1 is 0. And 0 plus 0 is 0. And 0 plus 5 is 5. 6 plus -1 is 5. Okay. And 1 plus 0 is 1. And 1800 plus 25 is 1825. Okay. Now, when you see that bottom contains no negatives, you know that we have arrived at the optimal solution. Whatever this says, that's the answer. We're done. Okay, so let's just read the solution. X1 is a basic variable. And remember, on a basic variable, you look at that number, it looks this number, X1 equals 25. And X2 is a basic variable, so we can look at this number, which makes us look at this number. 200 divided by 5 is 40. Okay, let's go ahead and look at Z. Z is basic. You look at that 1, which makes you look at this 1825. Z is going to equal 1825. And then let's go ahead and throw the S1 and S2 on there because that is technically part of the solution. We've got 2 non-basic variables. So both of those values are 0. That's your optimal solution. And if you go back and look, sure enough, that's exactly what we got up here. This point right here was our optimal solution. And I know you're like, well, yeah, that's going to be so much easier to just use Desmos and graph it. And that's fine as long as it's graphable. But as soon as I throw in more than 2 variables, you won't be able to use Desmos and graph it. And so that's what's good about this simplex method. So number 2 already has the Tableau, and it says we're going to maximize using that simplex method. So maximize using the simplex method. First thing you do is find the most negative indicator, which is this -25. Circle it. Then you go over here and look at the ratios. Okay. 100 over -2. That's not going to be positive, so I don't even need to look at that one. 200 divided by 4 is 50. And 150 divided by 0 is going to be undefined. So the one that I need to look at is this one. That's the smallest positive, because I didn't even look at the other ones. You can disregard this one because it has a negative. You can disregard this one because it has a 0 on the bottom. I'm only going to look at that 50, the middle row. Circle it. Also, you don't need to do that step on the bottom because the bottom is the objective function. We're only looking at the constraints. The number that I circled twice is my pivot element, and that's what I need to use to zero out the others. So check it out. I need to zero out a -2. I'm going to, what can I do here? 2 row 1s plus row 2. They give me -4 plus 4. That's going to be 0. Okay. So look at your variables. And let's use that row. 2 row 1s plus row 2. That's 2 plus 3. That's 5. And 2 of these plus this is 0. 2 of these plus this is 2. 2 of these plus this is 1. 2 of these plus this is 0. 2 of these plus this is 0 equals 2 of these plus this. That's going to be 400. The circled row is your pivot row. You don't need to do anything with that. So leave it alone. Underline. Check out the, oops, I shouldn't have underlined yet. I've got one more row, don't I? I've got a 3rd row. Don't forget about that. But the cool thing about that is it's already a 0. So there's no point in doing anything else. My objective is to change that into a 0. It's already a 0. So leave it alone. Now we'll underline. And at last I have to zero out this -25. using the 4. You always have to use the one that you circled. So a common multiple will be 100. I'm going to need 100 minus 100, or negative 100 plus 100, something like that. My rule I'm going to use is 4 row 4s plus 25 row 2s. That will give me negative 100 plus 100 is 0 right there where I want. Okay, so use that rule all the way across. 4 of these is negative 40 plus 25 of those. Let's go to a calculator. We've got 4 times negative 10 plus, what was it, 50? No, 25. 25 times 3. 35. Remember, as long as you don't see negatives down there, you're in pretty good shape. 4 of these zeros plus 25 zeros is 0. 4 zeros plus 25 ones is 25. 4 zeros plus 0 plus 25 zeros is still 0. 4 of these ones plus 25 zeros is 4. And 4 of these zeros plus 25 200s. 25 times 200 is 5,000. Box it. And I'm pleased, I'm happy right now because I don't see any negatives. So that means I've reached the optimal solution already. All that's left is just to read the solution out of that table. X1 is non-basic. Remember, non-basics are always going to be 0. So you've got a couple of non-basic and the rest are basic variables. X1 is going to be 0. X2 is going to be 200 over 4. Remember, you've only got one number. So look across, 200 divided by 4 is 50. S1, you got to look at this 2, and so that forces you to look at the 400. 400 divided by 2 is 200. S2 is basic. No, sorry. S2 is non-basic, so that's 0. S3, 150 divided by 1. And then Z is 5,000 divided by 4. 1250. Optimal solution. Looks like we're maximizing. All of these problems are maximizing problems, by the way. So the maximum Z value would be 1250. Okay. Now, if you're thinking about this graphically, I've only got 2 variables, x1 and x2. So technically, I suppose we could have graphed this one in 2 dimensions and looked at the corners. You could have done the method of corners, but you can do the simplex method for anything. Number 3, goats and pigs. Here's another one that we've done before. We've already done this example. And so it's nice to go back and look at the setup, but we're going to do it by simplex method this time. So how many goats and how many pigs? That's X and Y. And we're maximizing total profit. So go back and everywhere it says goats, put an X, and pigs, put a Y. So no more than 16 animals, no more than 10 goats, 25 to raise a goat, 75 to raise a pig, 900 available. So that means that she can spend $8.99. That's another less than or equals. Each goat produces $12 in profit, and each pig $40 in profit. Okay, oh, goats was right here, was X as well. So let's set up the problem. This is review right here. We're maximizing, and you can use Z or you can use P, it doesn't really matter. But find the number that's talking about profit. Looks like 12. 12x plus 40y. And then our constraints, subject to. And we go back through. No more than 16 animals means x plus y is less than or equal to 16. No more than 10 goats means x is less than or equal to 10. She spends 25 to raise and 75 to raise and has 900 available, so that's 25x plus 75y is less than or equal to 900. I think that's it. Okay. Now you can add on this extra step where both of those things have to be not negative. We don't want negative goats and pigs, but there you go. That's kind of your setup. So what do we need to do? We need to write our initial simplex tableau. So put in slack variables for each of the main constraints. There's 1, there's 2, there's 3. So on the setup, you'll need to list out the variables first. So you've got an x and a y, S1, S2, S3, and we used z. So go to your first inequality. You've got x plus y plus S1. You don't have any S2, S3, or z, and then it's equal 16. Remember what a slack variable does. It changes an inequality into an equals. We needed that for this matrix, for that vertical bar. The second one says 1x. There are no y's and no S1s, but there is an S2. No S3, no z, and it equals 10. Third one, 25x plus 75y. No S1, no S2, we've got an S3, and it equals 900. And then don't forget, there's a very common mistake that people will make, is they'll forget to put it in standard form. It has to be in standard form, so you have to subtract those variables over. Think about it. We need those to be negatives so we can go through the process. If you didn't see any negatives, then you wouldn't have any process to do. Don't have any slacks because it was already in equals. Don't forget your z, and then once you move all that out, it equals 0. There's your initial simplex tableau, and you can see that it's not optimal because of the negatives. And so we have to go through this process. This process says find the most negative indicator and circle that column, this negative 40. Then go through your columns and divide. 16 over 1 is 16, and 10 over 0, you can ignore that one, and 900 over 75, don't know what that is. 12. And so 12 is your least positive indicator, or ratio rather. 12 is less than 16, so we circle that one. The number that we circled twice is our pivot element. That's our pivot element. That's the one we need to use to zero out the others. Now the good news is you need to change that to a 0, but that one's already a 0. So 1/3 of the steps would already have been done for us. Okay. So let's rewrite the table. Sometimes students will try to get lazy on this lesson, and there's really no way to get lazy. So don't be lazy. If I'm looking at that 1 and I want to get the 1, I want to get rid of the 1 using the 75, then I would have to, let's see, what can we do? 75 row 1s minus row 3. That'll do 75 minus 75 is 0, right there where we want it. So do that all the way across. 75 of these minus this is 50. 75 of these minus this is 1. No, that's 75, sorry. 75 zeros minus 0 is 0. 75 zeros minus 1 is -1. 75 zeros minus 0 is 0. Bar. 75 16s minus 900. Need a calculator. 75 of the 16s minus 900. is 300. Now the middle row is already a 0, so leave it alone. Don't mess it up. If it's already a 0, take it and run. 75, the circled row, is your pivot row. You don't need to mess with that either. Sometimes I'll have people try to make that into a 0, but you don't want to. Just leave it alone. Bottom row, we need to get rid of a 40 using a 75, and that's kind of tough. I don't know the least common multiple of those two numbers, but I don't need to really, because all I really need to do is say 75 row 4s plus 40 row 3s, and even though I don't know what those totals are, I know that that's going to produce 0. 75 times negative 40 plus 40 times 75 is definitely going to be 0. So let's just use that rule. We've got 75 times negative 12 plus 40 times, what is it, 25 is 100. Okay. 75 zeros plus 40 zeros is 0. 75 zeros plus 40 zeros is 0. 75 zeros plus 40 ones is 40. 75 ones plus 40 zeros is 75. 75 zeros plus 40 900s. $36,000. And we're pretty happy about this at this point because we know we're finished. When you don't see any negatives in this bottom row, we know we have the optimal solution. So all that's left is just to read that solution. X is non-basic, so that means X is 0. Y is basic, so you're going to have to do 900 divided by 75. You look at this number, which makes you look at this number, you divide 900 divided by 75 is 12. Perfect. S1, 300 divided by 75 is 4. S2 is 10 divided by 1 is 10. And S3, that's non-basic, so that's 0. And then Z is 36,000 divided by 75. 480. Okay, 480. Now you may remember that number, or those numbers, because we've solved this problem before. This was a story problem. It has context, so make sure you put your answer into context. X was goats and Y was pigs. So this solution meant the maximum profit was $480, raising 0 goats and 12 pigs. Now, one of the cool things about a story problem is it can help us to try to think about what a slack variable represents. If you go back and look at your inequalities, that first inequality, x plus y is less than or equal 16. Well, if you think about the S value for S1 was 4, remember what a slack variable does. It turns an inequality into an equation. So if x was 0 and y was 12, and your S value is going to be 4, that makes 16 right there. 0 plus 12 plus 4 is 16. And then your second inequality, notice your S2 value was 10. And so your X value if your x value is 0, let's see. Well, I guess it doesn't make sense to have an xy table since there's not a y variable there. But if you think about, forget about your table for a second. If x is 0, then there's still room for 10 more, whatever we're talking about. What are we talking about? Goats? There's still room for 10 more goats to be inside that inequality. And then if you look at the third one, S3 was 0. S3 was 0. And if you think about 25 times x was 0 plus 75 times 12. Okay. Basically, we're doing 75 times 12 here. 75 times 12 is exactly 900. There's no room for slack. There's no extra space. And so the slack variable is just saying if there's any more room in our inequalities, we're going to pick up the slack with those slack variables. But as for the upshot, the important part is this solution. The maximum profit is $480, raising 0 goats and 12 pigs.